get started. It is Thursday morning at 9 a.m. and we're getting the show on the road. So, question number 1 says the following. A store owner made a list of the number of videos sold last month. The store sold 167 comedies, 285 action movies, and 56 romantic movies. Oh, also, we are on page 1, 2, 3, 4, 5 of our packet right now. We're on page 5 of the math section of the packet. Based on this data, which number is closest to the probability that the next customer will buy an action movie? So we're looking for the probability of an action movie. How do we calculate the probability of an action movie? Or how do we calculate the probability here? For an answer from somebody, how do I calculate the probability of finding an action movie, or that the next person will buy an action movie? What is my ratio going to look like? In words, what's going to go on top and what's going to go on bottom? In words, what's going to go on top and what's going to go on bottom? Excellent. We're going to do number of action movies. Actually, I'm going to show call this. I'm going to put the number of action movies over the total. I'm so sorry, everybody. So probability of action, I didn't write too much this time, is going to be the number of action movies over the total number of movies. And how many action movies did we have? How many action movies did we have? How many action movies do we have here? We had, right, 285 action movies. And how many total movies does the store owner have? How many total movies does the store owner have? Or rather, what's the total number of movies the store owner sold? Excellent. We have 508 movies sold. And these are all in decimal form. So 285 over 508 is going to be what? 285 over 508 is going to be what? .285 over 508 is what in decimal form? See, one person got it. For at least one or two more to get it. 285 over 508 is what in decimal form? Awesome, yep, a bunch of people got it now. 0.56, which means that our final answer is going to be D, 0.56. So the based on this data, the probability the next customer will choose an action movie is 0.56, or a little bit over 50%. Awesome. Any questions so far? Any questions so far? All right, awesome. Let's keep moving on. So, question number 2. Question number 2. The spinner shown below will be used to play a game. If the pointer on the spinner is spun 120 times, how many times do you expect the pointer to stop on a color other than red? Looking for any color other than red. So how many sections of my spinner are there? We have 1, 2, 3, 4, 5, 6, 7, 8. And how many red sections do I have? Let's see. This section's red. 1, 2, 3 sections are red. So how many sections are not red? Awesome. A bunch of people got it. Probability of not red is going to be our 5 non-red sections over a total of 8 sections. And what are we going to set that equal to? What will we set that equal to? Determine how many times we land on not red if we spin it 120 times. Awesome, yep. One person's got it. I was gonna get it. So 5 out of 8 was our initial ratio here. And we want to see what that's going to equal to see how many times we land on not red if we spin it 120 times. So I want to see what it's going to equal if we spin it 120 times. Love the participation this morning, though. Excellent. Yep, 2 people got it. It's going to be x over 120. This is going to tell us how many times it was not red. There we go. We got it now. Over 120 total spins. So how do we solve for x? How do we solve for x? Right, butterfly method, cross multiplication. So we have 8x equals 5 times 120. 8x is just 8x. 5 times 120 is going to give us 600. Divide both sides by 8. And what is x going to equal? If we spin the spinner 120 times, how many times do we predict that the pointer will stop in a color other than red? What is x? What is x going to be? What is x going to be? See, one person's got it. Who else can get it? Austin got the answer 1 in now. Let's send a quick message to someone. So we all got it now. X is going to be equal to 75. So based on this, we can say that if the spinner is spun 120 times, we predict it will stop on a color other than red 75 times. Awesome. That's what we're going to do there. Great. So for those of us that just joined us, we are on page 5 of our math packet. We are on page 5 of the packet, and we are working through the problems on that page. Alrighty, let's hop to question number 3. Shayla has a number cube that is numbered 1 to 6. Should be 1 to 6 there. There is a different number on each side of the cube. If Shayla rolls the cube 50 times, correct how many times do you expect the number with the side 4 to land face up? So we're finding the probability of the number cube landing on 4 over the course of 50 rolls. So what is my setup going to be? Who can give me both fractions? Who can give me both fractions? One fraction. What is my setup going to look like? What do we think? Flying our number cube, it's going to land on 4. We're going to see how many times we get 4 if we land on it. Some feedback to people. Awesome. A bunch of us got it here. So we're going to get 1 over 6. Only one side of our cube has a 4 on it, so that's going to be 1 over 6. And we're going to set that equal to x over 50. We want to see how many times it lands on 4 in 50 total rolls. So once again, we're going to cross multiply, one of our favorite things to do. One of my favorite things to do, at least. And we get 6x equals 50. Divide both sides by 6. And we're going to get x is going to equal what? X is going to equal what? 50 over 6. What is that? We're going to 8.3 repeating. So we can say it'll land on 4 approximately 8 times. The number cube will land on 4 approximately 8 times. Awesome. There we go. Great job, everybody, on that problem. That was good work. We got a lot of participation. I think everyone participated in that one. Very happy with everybody here. So question number 4, if a coin is flipped 70 times, how many times should it land with tail side face up? So for this one, I want everyone to do it independently. I'm actually not going to spend time on it now. But I think we're all set up for this one pretty well. I want everyone to work on this independently and then answer that in the Google form that I'm going to send out to everyone one more time. And also in the packet independently, okay? If you have any questions about it, feel free to message me afterwards. Happy to go through it afterwards, but I want us to do some of these problems on our own, so we're gonna do this one on our own. All right, but we are gonna take a look at number 5 together. So, a bag of colored marbles includes 6 red marbles, 4 orange marbles, 5 yellow marbles, and 9 green marbles. Caleb randomly selects a marble and then puts it back in the bag. He does this 12 times. How many times would you expect he selects a red marble? So, find the probability of a red marble is going to be, let's see, we have 6 red marbles. And how many total marbles do we have? How many total marbles do we have? How many total marbles do we have? One person got it. How many total marbles do I have? So you have 6 red marbles plus 4 orange marbles, that's 10 total marbles. Plus 5 yellow marbles gives us 15 marbles, plus 9 green marbles, that's going to give us 24 marbles. And then what are we going to set that equal to? What will we set that equal to? What will we set that equal to? I don't know what happened to our participation here. A lot of people here that need to participate. What are we going to set this equal to? Send everyone a message who's not participating. Not quite the total. We're looking for, he does this 12 times after he puts it back in the bag. So how many times do we expect he selects a red marble? I want a little more participation here out of us. Yep, awesome. So we're gonna have x over 12. We're looking for how many times he selects a red marble over the 12 total times that he pulls the marble out of the bag. How do I solve for x? How do I solve for x? Cross multiply, excellent. So we get 24x. It's going to equal 12 times 6. 12 times 6 is going to give us 72. And we divide both sides by 24 to solve for x. And what's my final answer going to be? What is x going to equal? What is x going to equal? What does x equal? What does x equal? Yep, one person got it. Or at least 2 more. What is x going to equal? So with 24x, we divide both sides by 24. So we just get 1x, or x, equals, excellent. It's going to equal 3. Awesome. So if we pull 12 marbles out of the bag and replace them each time, we predict that we will pull 3 red marbles out. We predict that 3 of those marbles are going to be red. Any questions? Questions here? did this a little while ago, but I feel like we should be pretty strong at it. We were really good at it in class. Alrighty, amazing. So let's hop on to the next question. We're going to do page 6 of our packet. Now we're looking at page 6 of our packet. Alrighty, we're doing question number 1 on page 6 of our packet. So question number 1 says, Sean will use the spinner below to play a game. There's an equal probability that the pointer will land on each number. Makes sense? So each section of the spinner is the same size. The spinner is spun 1,000 times. How many times would you expect it to stop on the number 1 or the number 4? So our probability of 1 or 4 is going to be, how many sections of the spinner have either a 1 or a 4 on it? How many sections have a 1 or a 4 on it? Right, exactly. There's going to be 2 sides that have a 1 or 4 on it. We have this side here and this side here. And there's 8 total sections. And we're going to set that equal to what? What are we saying that equal to? What are we saying that equal to? Awesome, exactly. X over 1,000. Trying to see how many times it lands on 1 or 4 out of 1,000 total spins. So we cross multiply. We get 2,000 equals 8x. Divide both sides by 8. And 2,000 over 8, I can just give it to us, is going to be 250. So if we spin the spinner 1,000 times, we expect it will stop on 1 or 4 250 times. If we spin the spinner 1,000 times, we expect it will stop on 1 or 4 250 times. Awesome. Let's take a look at question number 2. Gail purchased 5 raffle tickets. The grand prize is a vacation to Aruba. Have fun. A total of 1,500 raffle tickets were sold. There's only one grand prize winner. What's the probability that Gail will win the grand prize? Not sure what we're doing there, but okay. So we're looking for the probability that Gail wins the grand prize. What do you think our setup has to be here? What will our ratios be here? What are our ratios going to be here? So we one person get it. I'm going to show call their work because they did it really well. So we have her 5 potential raffle winning tickets over 1,500 raffle tickets that are sold. And I want to see if she wins, but there's only one winning prize. So it's going to be 5 over 1,500 equals X over 1. Her potential for winning a ticket over the one winning ticket that's going to be sold. So we cross multiply here. We get 5 equals 1,500x. We divide both sides by 1,500. And 5 over 1,500 is going to be 0.003 repeating. That's going to be x. So you can put this into a sentence for me. You can put this into a sentence for me. What is the probability that Gail wins the grand prize? Put it in a percent. Right. Probability is going to be less than 1. Let's be a little bit more specific than that. Let's be a little bit more specific than the probability being less than 1. Let's put it in a percent. Awesome. I've seen a couple answers roll in. We had one scholar really nail it on the head. Gail has a 0.3% chance of winning the grand prize. To make this into a percent, we're going to move our decimal point over 2. And we have approximately 0.3% chance of winning the grand prize. So it is not very likely that Gail is going to win the prize. It's possible, but it's going to be fairly unlikely. Oops, sorry, I didn't send this to everybody. There it is. All righty. Let's keep moving and grooving. I think we are. Yeah, we are going to skip not skip question number 3, but I want you to do question number 3 on your own. I want you to do question 3 on your own. Do on your own. And do question 3 on your own. I'll be looking at your answers in the packet and then on the Google form that you need to fill out. Do this one on your own, okay? Question number 4. The probability of selecting each card in a deck of cards is 1 out of 52. That means that there are 52 different cards in the deck. There are 4 aces in a deck of cards. What's the probability of selecting any card other than an ace? So, how many cards are not aces? How many cards are not aces? How many cards are not aces if 4 of the cards are aces? Right, exactly. 48 cards are not aces. And there's how many cards in the deck? 52, exactly. And what are we going to set that equal to? What will we set this equal to? How many cards are we drawing out of the deck? How many cards are we drawing from the deck? So we're not drawing 52 cards, right? We're drawing any card from the deck, so we're only going to draw 1 card from the deck. If we're only drawing 1 card, what should our ratio be? Not quite. So on top is going to be X, our probability of drawing any card but an ace. And then on bottom, we're only drawing 1 card. So it's going to be a 1 on bottom, going to be a 1 on bottom there. So it's going to be a very similar setup to last time. We have a probability of not drawing an ace over the total number of cards equals that same not ace over the 1 card that we're going to be drawing. So let's cross multiply. We get 52x equals 48. We divide both sides by 52. And what's 48 over 52? 48 over 52 is going to be 0.92 approximately. So that means we have a 92% chance of drawing any card but an ace. We have a 92% chance of drawing any card but an ace. 92% chance of drawing any card but an ace. All right, we got 2 problems left. Let's see how quickly we can move through these so we can get you out within my half-hour time I always promise and never seem to keep. All right. Melissa has a collection of different colored hair bows. Some of the hair bows are big and some of the hair bows are small. The chart below shows how many of each type of hair bow is in Melissa's collection. What's the probability that the hair bow selected will be big and pink? How many hair bows are both big and pink? How many hair bows are both big and pink? How many hair bows are both big? So we have big right here. And then we have my pink category right here. Where's the intersection between big and pink? Where's the intersection between big and pink? Where's the intersection between big and pink? Come on, folks, need a little bit more participation here. Right, exactly. We're going to have 7 bows that are big and pink. So the probability of big, that should be B, and pink is going to be 7. And how many total bows does she have? How many total bows does she have? Scene 1. At least 1 more. Come on, folks. I know it's early, but we're almost done here. It's actually, oh, this is our last problem. Excellent. 7/55. As you may have noticed, we don't actually have to set this equal to x over 1. That just means we're going to be dividing. So we can skip that step altogether here. So 7/55 is what? 7/55 equals what? 7/55 equals what? $7.55 is going to equal what value? Excellent. 0.12 approximately. So there's a 12% chance that if she pulls out a bow, it's going to be both big and pink. Awesome. So that's going to be all we have for today. Make sure you're doing the homework and putting in the classwork stuff. However, before, oops, sorry, put the wrong thing. Before anyone goes, no one needs to leave yet. No one leaves yet. We need to go over Google Classroom first.